So our topic today is integration by parts using cubed integrals. This is a common Calc BC strategy that we will notice on the AP exam. What this unit is about is basically if you look at a function and notice that you can't really individually integrate it by using properties of integrals, your memorized antiderivatives, your u subs, you do something called integration by parts. So, what we do here first is we notice that we can't solve for this, so um, we're gonna have to rewrite this integral as cosecant cubed of x times cosecant of x dx. And I'm gonna introduce you guys I'm gonna let you guys know the integration by parts formula, since we are gonna apply this for these problems. So the integration by parts formula is u dv equals uv minus v du. Integral of v du. Okay, so while we need to identify our u and dv first, is u is something that is going to be derivable. Cosecant of x is easily derivable in this situation, so our u is going to be cosecant of x, and then dv is going to be whatever's left over, so it's going to be cosecant squared of x dx. U can be derivable, so du is going to be negative cosecant of x cotangent of x dx, and dv is going to be negative cotangent squared, cotangent of x, not squared. Alright, and now we're going to replug that back in. Equals u times v. Why did I write dv down there? That's supposed to be v. Okay, negative cosecant of x cotangent of x minus the integral of v du. So it's going to be negative cotangent of x times negative cosecant of x cotangent of x dx. These negatives will cancel out. Let's simplify that. Negative cosecant of x times cotangent minus cosecant of x times cotangent squared of x dx. Alright, so cotangent squared of x, this is one of our formulas that we had to remember. So I hope you guys remembered this from pre-calc. Sine squared of x plus cosine squared of x equals 1. Remember that cosine over sine is cotangent. So we're going to divide everything by sine squared of x. Sine squared of x over sine squared of x is 1, plus cotangent squared of x equals 1 over sine squared of x, which is just going to give us cosecant squared of x. We're going to subtract that by 1. And then we're going to have cotangent squared of x equals cosecant squared of x minus 1. And now we're going to re-plug that back into our formula here. So it's going to be cosecant cubed of x dx equals negative, can't write that negative there, it's complicated. Negative cosecant of x cotangent of x minus, we're gonna factor that. So CSC cosecant cotangent squared of x is equal to cosecant squared of x minus 1. And we're gonna add the dx at the end. Alright, so now we're gonna simplify that. We're gonna FOIL inside. Cotangent of x minus, what is cosecant of x times cosecant squared of x? That's gonna be cosecant cubed of x minus cosecant of x dx. And now we're gonna factor in that negative in front of the integral. So it's going to be cosecant cubed of x dx equals negative cosecant of x cotangent of x minus integral of CSC 3x dx plus CSC of x dx. Now we're going to add this to both sides. Oh, why did I cancel that? That's not supposed to be canceled. You're going to be left with 2 equals plus this. So basically I just rewrote everything so far, and now we're going to integrate this little guy right here, which I will bring down here. We're going to multiply this by 1, but 1 in this case, 1 is equal to 4 over 4, right? Same number over same number, or same function over same number, same function over same function. So 3e to the negative 3x over 3e to the negative 3x, they both equal 1, right? Well, we're gonna do something a little bit different here. It's kind of a little bit complicated, but it's pretty self-explanatory. We're gonna multiply by 1, but we're gonna do it in CSC of x times, not times, plus cotangent of x. We're going to multiply that by the numerator, the cosecant of x, this guy. And now when you factor that into the insides, you're going to get cosecant squared of x plus cosecant of x cotangent of x over cosecant of x plus cotangent of x. And now you're going to u sub this. We're going to u sub the denominator. So u equals cosecant of x plus cotangent of x. The derivative of this is going to be negative cosecant of x cotangent of x plus, not plus, minus cosecant squared of x. And now we're going to replace the denominator with u, and we're going to factor out a negative here. So it's going to be du equals negative cosecant of x cotangent of x plus CSC squared of x. Then we're going to divide both sides by -1, so it's going to be negative du. equals CSC x cotangent of x plus CSC squared of x. And we're going to replace that with negative du. Or we could rewrite it as that. If you memorized your integrals, this is going to be the natural log negative ln of u. And then we're going to rewrite that as negative ln of, we're going to reinforce the u function into this, which was CSC of x plus cotangent of x. And now we're going to plug that back in to this equation here. So 2 times the integral of CSC 3x dx equals negative cosecant of x cotangent of x minus ln of CSC of x plus cotangent of x plus c. We're not quite done yet. Now we're gonna divide both sides by 2 to isolate that, and the cubed integral, the integral of cosecant cubed is gonna be negative 1/2 cosecant of x cotangent of x minus 1/2 ln of CSC of x plus cotangent of x. I'm gonna move all of this and I'm gonna put it underneath. You know what? I'm gonna move it. Let's move it. I'm gonna make it shorter and then move it back up. Equals minus 1/2 ln of CSC of x plus cotangent of x plus c. And then there you go. This concludes question 1 of 2. It's a pretty long process, but if you memorize the process in which you know how to apply integration by parts in u-subs, and you know your pre-calc trig functions and your trig identities, this will be a piece of cake for you. Alright, moving on to question number 2. We're going to do secant cubed of x dx. It's very similar to cosecant of x. So we're going to rewrite this as secant squared of x times secant of x dx. And then we're going to apply that integration by parts formula again. I'm going to turn that into a different color. Let's set that pen tool aside. U is going to be the derivable function, which is going to be secant of x, which our du will be secant of x tangent of x dx. And then our dv is secant squared of x, and that's going to be dx, and v is going to be tangent of x. Now we're going to reinforce that back into our original equation, into our original formula. So we're going to put it back here. So now it's going to be, no integral uv minus udv. VDU. Okay. Factor which is going to give you secant of x times tangent squared of x dx. Now this can be rewritten as one of our trig identities. Sine squared x plus cosine squared of x is equal to 1. Sine over cosine is going to equal tangent, so we're going to divide everything by cosine squared of x. Tangent squared of x plus 1 equals secant squared of x. Subtract by 1. Which gives us that. Now we're going to reinforce that back into our equation. There we go. And then we're gonna FOIL that in. All right. And now that we done all the algebra, we're gonna factor in that negative in front of the integral. So it's going to be negative secant cubed of x plus secant of x. I'm not going to put the dx for this. It's not really that significant in this problem right now. That way I can just reserve space. Now I'm going to clear this. And then add that there. So it's going to be something like this. We are almost done. All we need to do is that u sub and we are good. All right. So now we're going to reinforce that here. Secant of x times 1. So it's going to be secant of x what in the world? My iPad is glitching. The reverse button is lagging. Okay, that is my apologies. Times secant of x tangent of x over secant of x tangent of x plus, don't forget the plus. Okay, so that's going to be secant squared of x plus secant of x tangent of x over secant of x plus tangent of x. U sub. Derivative of that is secant of x plus secant of x tangent of x plus secant squared of x, which is basically this. All right. Now we're going to plug everything back in. Du over u. That's going to be 1 over u du, which equals ln of u. We're not going to add the plus c yet. We're going to add that after the reinforcements. So ln of secant of x plus tangent of x. And that's our answer for this integral here. And then now we are going to plug everything back in together and reassemble this equation. So it's going to be 2 equals secant of x tangent of x plus ln of secant of x plus tangent of x. Why did I put that outside of the thing? And then we're going to divide everything by 2. So now our complete equation here is secant cubed of x. The integral of that is equal to secant of x tangent of x plus, oh, don't forget the 1/2. 1/2 ln of secant of x plus tangent of x plus c. And this concludes the video. This is a lot to take in for 2 questions, but it's not really too complicated. I would say series is definitely harder, second semester, but know how to apply this in case Mr. Rodriguez puts this on a test or quiz, which he definitely will, and you should be good because the other integration by parts steps is baby steps. So yeah, thank you for watching.